Hello children, today we will learn how to check whether the function given is continuous or not. So let us define this continuity. So a function f of x is said to be continuous. Let the function is continuous at a point a. So a function f of x is said to be continuous at x equals to a if the left hand limit of the function, the right hand limit of the function, and the value of the function at a point x, if all are equal, okay, if all are same. So we will write left hand limit of the function is equals to right hand limit of the function and the value of the function at point A. Now left hand limit means limit x tends to at which point? At point A. So we'll write a minus f of x. And how to write right hand limit? We will write limit x tends to a plus f of x, and here the value of the function at point a, f of a. Now we have studied in detail in class 11 how to find left hand limit and right hand limit, means the chapter limit we have already studied in class 11, but I will explain in brief. Here point a and all the values which are here on the left hand side. Okay, so there are two ways we can approach this a. First from the left hand side and second from the right hand. So here the value, the function is approaching from the left hand side. Okay, so here all the values will be less than a. So that is why we will write a minus. It's not minus a, it's a minus, means all the values less than 1, less than a. And here the function is approaching from the right hand side, and on the right hand side on the number line all the values are greater than a. Okay, so we will write a plus, means values greater than a. So now how to find this left hand limit and right hand limit? So we'll write limit h tends to 0, where this h is a very small value. Okay, this h approaches 0, here x approaches a. Okay, so here h approaches, or h, how to read? Limit h tends to 0 f, this is a minus, so we will write, so it's a minus, so a minus x. And how to find right hand limit? Limit s tends to 0 f of a plus, so a plus x, and this is the value of the function at point a. So this is definition of a function. So a function is said to be continuous if its left hand limit, right hand limit, and value of function at a point all are same. Okay, now let us discuss few examples, few questions. I am taking first question of the exercise 5.1. question number 1. Question is, prove that the function f of x equals to 5x minus 3 is continuous at x equals to 0, at x equals to minus 3, and at x equals to 5. So one by one we will prove that the function is continuous at points 0, 3 and 5. So the first part is, we have to prove that the function is continuous at point x equals to 0. So we will use the definition of continuity. Okay, we will check whether the left hand limit of the function, right hand limit of the function, and the value of the function at a point. At which point? So we have to check at point 0. So this is this is our a. Okay, in the definition what the function is said to be continuous at point a. So here a is 0. This the point. In the second case, the value of a is minus 3. Here a is 5. Okay, so at which point we have to check? At point 0 we have to check whether the function is continuous or not. So first we will find the left hand limit of the function at which point? At point 0. Okay, so left hand limit x tends to 0 minus means all the values less than 0. Okay, so limit x tends to 0 minus f of x, this we have to find, which is equals to limit h tends to 0. Okay, now what we will do, we'll put the value, okay, we'll put x equals to 0 minus h limit f 0 minus. Now see, f of x is given 5x minus 3. We are given f of x equals to 5x minus 3. How to find f of 1? By putting x equals to 1. Okay, 5 multiplied by 1 minus 3. How to find f minus 2? By putting x equals to minus 2. How to find f 100? By putting x equals to 100. Okay, similarly, how to find f 0 minus h? By putting x equals to 0 minus h, or simply 0 minus h means minus h only. So similarly, how to find f minus h? By putting or by replacing this x with this minus h. So f of x is 5x minus 3. What about f of minus h? 5 minus h minus 3. So limit h tends to 0, 5 minus h minus 3, which is equals to limit s tends to 0 minus 5h minus 3. Now we can put limit. So 5 multiplied by 0 is 0. 0 minus 3 is minus 3. So now here the left hand limit is minus 3. This is linear. We can directly put the value, since here if you put the value directly you won't get 0 by 0 or indeterminate form, so you can directly put also, but most of the time or in maximum question we use this method, so I'm using this method. Otherwise you can directly also put, because we are not getting 0 by 0 form, right? So now we will find the right hand limit. We will find right hand limit x tends to 0 plus f of x, which is equals to limit h tends to 0 f of 0 plus h, or simply limit h tends to 0 f of h. Now fx is given, we are given fx equals to 5x minus 3. What about f of h? We just replace, okay, at the place of x we will write h. So limit h tends to 0, fh will be 5h minus 3. Now we will put limit. So 5 multiplied by 0 is 0, minus 3 is minus 3. So RHL is also equals to minus 3. Now we only need to find the value of the function at the point. At which point? We have to prove the continuity at point 0. So we will find the value of the function at point 0 only. Okay, so we are given f of x, how much? 5x minus 3. How to find 5f0? By putting x equals to 0. So 5 multiplied by 0 minus 3, 0 minus 3, which is equals to minus 3. So it is clear that this left hand limit is equals to right hand limit is equals to value of the function at point 0. All are equal. So we can say f is continuous at x equals to 0. Okay. Now we will prove that this function is also continuous at point minus 3 and at point 5. These are the second and third part. So now we will prove for x equals to minus 3. Okay. So we will repeat the same procedure, the same steps. First we'll find the left hand limit. Okay. So left hand limit will be limit x tends to minus 3 minus f of x, or limit h tends to 0 f minus 3 minus h. Okay. Now f of x is given. F of x is 5x minus 3. Okay. What about f of y? 5y minus 3. What about f of 1? Okay, so in the same way, what about f of minus 3 minus h? Means here at the place of x, now we have minus 3 minus h. So at the place of x, we'll put minus 3 minus h. So limit h tends to 0, fx, okay, here at the place of x, we have minus 3 minus h. So fx is fx is 5x minus 3. So this is 5x. Now at the place of x, we have minus 3 minus h and minus 3. Is it clear? Now we will simplify. So limit h tends to 0. Now we will multiply. Minus 15 minus 5h minus 3. Now we'll put the limit. Okay. So when you put the limit, you will get minus 15 minus here 0. 5 multiplied by h is 0. So minus 15 minus 3 is minus 18. Okay. Now we will find the right hand limit. Right hand limit. Limit x tends to, at which point we have to find? At point minus 3. So limit x tends to minus 3 plus f of x, which is equals to limit h tends to 0, f of minus 3 plus h. Okay, and we are given f of x equals to 5x minus 3, means now this is our x. fx means at the place of x, now we will put minus 3 plus h. So we'll get limit h tends to 0, 5x. Now x is minus 3 plus h and minus 3. Now we will simplify. H tends to 0, minus 15 plus 5h minus 3. Now we will put the limit. So when you put the limit, this term will become 0. Minus 15 minus 3 is minus 18. Left hand limit is minus 18. Right hand limit is also minus 18. We only need to find the value of the function at the point. At which point? At minus 3. Okay, so the function is given 5x minus 3. We have to find f minus 3. Means at the place of x, we will put minus 3. So 5 multiplied by minus 3, minus 15, minus 3, minus 18. So it is clear that the left hand limit is equals to the right hand limit is also equals to the value of the function at point minus 3. It means f is continuous at x equals to which point? Minus 3. Okay, so this is how we can prove, that function is continuous at a point or not. So now the third part is for you, for homework. You have to prove that the function f of x, which is equals to 5x minus 3, is continuous at point x equals to 5. Now let us see second question. The question is, examine the continuity of the function. We are given a function f of x is equals to 2x square minus 1 at x equals to 3. Means we have to prove that the function, or we have to check whether the function is continuous at point 3 or not. Okay, if a function is not continuous, then it is called discontinuous. So we have to check whether the function is continuous or not. So the process is same. We will find the left hand limit, the right hand limit, and the value of the function at point 3. Okay, so here first we will find the left hand limit. Limit x tends to 3 minus f of x, which is equals to limit h tends to 0, f 3 minus, so 3 minus x. Okay, now f of x is this 2x square minus 1. What about fy? 2y square minus 1. What about f1? 2 1 square minus. What about f10? 2 10 square minus 1. What about f 3 minus h? Okay, what about f 3 minus x? We'll simply put 3 minus x where? Here only. Okay, and be careful, this is 3 minus h. Okay, actually what, if you remember, then what we do after this step, what we do, we put x equals to 3 minus h. Okay, so now the equation is in the terms of h, so we need to write the limit also in the terms of h. So here, as the x approaches 3 minus, okay, x approaches 3 means if you put x equals to 3, what will be the value of h? Okay, if you put x equals to 3, here x approaches 3 means when you put x equals to 3, what will be the value of h? So when x is 3, h will be 0. Okay, that is why we will get h tends to 0. The function is in the form of h, that is why limit of h, right? So here fx is this, so we'll put, means this is our x, so we'll get 2, don't forget to write limit h tends to 0 to x square, this is x now, so x square means 3 minus h square minus 1. Okay, now we will simplify. So limit h tends to 0, here we can use a minus b the whole square identity, we can use. Okay, now we will multiply. Since we are doing this question for the first time, so I am writing the solution in detail. If you want, you can skip this this 1 or 2 lines. Now we'll put the values of h. So we'll get 18 minus 1, which is equals to 17. Okay, now similarly we will find the right hand limit. Limit at which point? At point 3. So limit x tends to 3 plus f of x. Now we will write in terms of h. So limit h tends to 0, f 3 plus. So we will write 3 plus h. Okay. Now we are given f of x equals to how much? 2x square minus 1. So we'll put, or we'll find f of 3 plus h. Now at the place of x we have 3 plus h. Okay, we have 3 plus h. So limit h tends to 0, 2x square means 2, x means 3 plus h square minus 1. Okay, so when you simplify, you will get 3 plus 0, 3 square is 9, 9 2s are 18, 18 minus 1, 17. So the right hand limit is also coming 17. Now we only need to find the value of the function at point 3. So this is our function 2x square minus 1. F of x is 2x square minus 1. So what about f of 3? 2, 3 square minus 1. 2, 3 square is 9 minus 1. So 18 minus 1 is 17. So clearly the left hand limit is equals to right hand limit is equals to the value of the function at point 3. So we can say that f is continuous at x equals to 3.